Okay, so problem 6.8 is a spring problem, which gives you a spring here and a block of mass of m, and the force exerted by the spring is given by negative k times x cubed, x here, which represents the displacement of the spring. So part A asks you to determine the potential energy in the spring at the instant the mass is released. So you would use the equation W, work, equals the integral of F dot dr, which makes sense because you have to do work in order to move the spring this much, and all that work is transferred into potential energy of the spring. So this would look like the limits of integration would be from 0 to a, because it asks you over here to assume that the spring is stretched a distance a. So F is given over here as negative k x cubed, right, times dr, which is your it's just the thing you're integrating with. So you would get negative k x to the fourth over 4, because that's what you integrated to get. This negative sign here doesn't really matter because it is a potential energy, and potential energy is always positive because it is a scalar quantity. So that's part A. Part B asks for the maximum speed of mass. So the maximum speed of mass is obtained when all the potential energy of the spring is converted into kinetic energy. So initial potential energy would have to equal final kinetic energy. So as determined part A, the initial kinetic energy is determined to be k times x to the fourth over 4, and kinetic energy, as I hope you all know, is 1/2 mv squared. Yes. So in order to find v, it's probably asking you to find maximum speed, which is v max, right? So first you would solve this problem. You solve for v, so v squared equals kx4 over 2. Move the m over here too, so it's over 2m. And then you get this, yes? And then so you do v equals square root of kx to the fourth over 2m. And that's your answer for part B. Part C asks to find the displacement of mass at a point where the potential energy of the spring and the kinetic energy of the spring of the mass are equal. So the potential energy and so the total energy system is given by potential energy PE plus kinetic energy KE. So at any one point, U total must remain the same throughout the entire system. So so at the point when PE equals KE, it doesn't really matter what you do. But when they're both equal, you can place them in the same value. So we'll call this new variable x. So x would equal 1/2 PE, because that is when 1/2 of the potential energy is converted into 1/2 of the max possible kinetic energy, which means that both of them will be equal. So so the PE max. So PE max is determined part A to be kx to the fourth over 4. So you would do Ka. Oops, this would be an answer vector. Sorry. Should I read it? No problem. Okay. K to the fourth. Explain it. For because this A, I forgot to carry it. I'm quite sorry about that. I'll just fix it for all these then. All right. So this is the potential energy when potential energy equals kinetic energy. So it'll be easiest to find the displacement of mass at the point where potential equals kinetic energy by using the potential energy of the mass of that point. So PE equals KA to the 4th over 8. So PE is given by kx to the 4th over 4, because you're basically replacing k with a with x, equals ka 4th to the 8. So these will cancel out, and then this x to the 4th would equal a to the 4th, right? And then over 2. So then x, you move this over here, would be the 4th root of a to the 4th over 2, right? Part D asks you to state whether the period of oscillation increases, decreases, or remains the same when the amplitude of oscillation is now increased. So since consider a spring with a force proportional to x squared, in this scenario, the amplitude of oscillation would be independent from the period, but since we're dealing with a force with the force proportional to x cubed, the amplitude of oscillation, if you increase it, would result in a decrease of the period, because as you increase force, you as you increase amplitude, you increase force by a lot more, which would then give you a shorter period. And that is how you do problem 6-8.